Hey everyone, this is Guru. I'm one of the co-contributors of the Waku project, and I do developer relations for Waku. In this Waku ecosystem spotlight, we have with us a special guest, Petco from the GraphOps team. So we have a couple of questions lined up for Petco, but to start with, Petco, can you introduce the graph to us, and can you also explain about the relationship between the graph and GraphOps?
Of course, hello and thanks a lot for having me. Before we start, I just want to highlight I'm with my Waku shirt today, and just I want to give a huge thanks and kudos to the whole Waku ecosystem. You guys are legends, and I'm just amazed by your full-fledged commitment to the mission of Web3. It's honestly remarkable. So thanks a lot for that. But now to jump into the question. So the graph is has been branded as a marketplace for Web3 data. And I know that that's a little convoluted, so I would prefer to just explain it with examples. So what the graph does is it allows for a decentralized indexing solution because, as we know, centralized indexing solutions are not the best thing. For one, they're pretty hard to properly construct, and then obviously they're subject to censorship. They're subject to service failure, like if the centralized the indexer has a bug and fails, then the data consumers can no longer get that data. So the graph aims to solve all of Web3's indexing needs. And this is beneficial to a wide range of use cases. I think it's most notably, its most notable benefits are probably in DeFi because, for instance, Uniswap and SushiSwap, they leverage the graph in order to get near real-time data on their web pages instead of trying to do that by themselves and spinning up their hosted infrastructure. So it's great for DeFi. It's also great for NFTs. A lot of NFT projects use the graph. It's great for stuff like live peer. It's even good for DAOs like um, ENS governance, and the whole ENS governance system also leverages the graph. So really, it's useful for a very wide range of use cases. I would say most projects in Web3 will definitely benefit from the graph. I don't think I'm over exaggerating, although I might be a bit subjective. Now, where does GraphOps fit? So the graph is not really one company. The graph is a protocol, and it's all of the development that's happening within the graph ecosystem is driven by the core developer teams. Now, I don't want to list all of them because I might miss one, but there's I think 6 or 7 core dev teams. The first core dev team is Edge and Node, which are the people behind the original graph project and idea. GraphOps is one of those core development teams. We're a pretty small team, and our focus is mainly on the data indexing side. So these core developer teams, they focus on different parts of the graph, and some of them focus more on the subgraph developer side of things. And just if anyone's not familiar, subgraphs are basically small programs that tell the graph network what data you want, like what data your app needs, and tell it how it should get processed and stored in order for the data consumers to fetch it later. But yeah, that's another thing. So some of the core developers focus on subgraph developer experience, but we at GraphOps, we focus on the indexer side. So we actively contribute to the indexing software, and we also develop a whole host of apps that are indexing focused. Just to quickly name a few, obviously we have GraphCast, which we'll talk more about today, which heavily uses Waku. Like Waku is the foundation for GraphCast. GraphCast is basically a domain-specific gossip network for indexers. But we also developed Launchpad, which is a Kubernetes-centric toolkit for indexers. And then since recently, we also have GraphSeer, which is this beautiful web interface that has very, very rich data around all of the indexers within the Graph network. And yeah, people can get a ton of useful insights from GraphSeer. So yeah, I hope that wasn't too long, but that's basically what the Graph is and how GraphOps fits there.
Amazing. So we've been hearing about GraphCast a lot. Can you tell us about GraphCast and also how do projects leverage using GraphCast?
Yeah, so GraphCast is one of the main efforts that we're focusing on in GraphOps. It's a project that's been kind of in the ideation phase ever since 2021, I believe. But really, we started developing it, I think, in the summer of 2022. Um, and it's basically this gossip network, but specifically for indexers in the Graph ecosystem. So the reason why the Graph ecosystem, and specifically indexers, but it's not limited to indexers because we're trying to add a new feature that can be used by subgraph developers and even data consumers. The reason we believe that the Graph definitely needs a gossip network is that the whole idea of the Graph is to be this fully decentralized indexing layer. So by virtue of that, you shouldn't rely on centralized communication, right? And there's basically two ways that all of the Graph participants, but specifically indexers, there's two main ways, or I should say three main ways that they communicate with each other before GraphCast emerged. So the first way to communicate would be on-chain. So maybe one indexer wants to sync the subgraph, but it's going to take a long time. But that indexer wants people to know that that they'll be syncing that subgraph, because when the subgraph is synced, the users will know that, hey, you can query data from me since I've already synced that subgraph. So the thing is, if an indexer, and this is a basic example, but there's all sorts of things that indexers might want to communicate with each other and with the wider network. So, but for this specific instance, if an indexer wants to do that, they can do it on chain. So they can post a transaction, and that would obviously be the most kind of web-free maxi way of communicating that you want to sync a subgraph, or that you have a failure in your subgraph sync and you want a subgraph developer to check it. So you can post the transaction on chain, signaling some kind of event. The problem with that, obviously, is that it costs gas, and especially before, when the Graph smart contracts were on ETH mainnet, especially during some gas spike times, it was very inefficient to communicate on chain. Now that the Graph is on Arbitrum, obviously it's a lot less expensive. But no matter how small the gas cost is, you're essentially putting a minimum price, so like a minimum value, for a message, right? So all of the communication that happens on chain has a minimum value, and if an indexer deems a message or a signal or an event or whatever they want to notify everyone about, if an indexer deems that that message isn't worth the gas cost, they're just not going to send it, which isn't good, because the network will flourish the more information it has among network participants. So that's why the first way isn't optimal. So the second way is the old-fashioned group chat, right? So there's like a Discord server channel or whatever messaging platform, and an indexer says, hey, I'm syncing this subgraph, or hey, I have this bug, please help. Now, I don't need to go into detail of the problems with that. There's a ton of problems. Obviously, they can hack your Discord profile. Obviously, someone can pretend to be you. Discord itself might go down. There's just, you guys know best. and everyone that is invested in Web3 messaging knows the flaws with that. And the third way, which is closely connected to that, is maybe indexers running bots or applications that automate messaging and event signaling. But all of those solutions before GraphCast were centralized. Like all of those solutions were centralized, except on-chain one, but it's not feasible in terms of cost. So given this inability of indexers to send messages freely, but in a way that is secure, in a way that is decentralized, in a way that could be private, in a way that's verifiable, there was just no way to do that. So this is where GraphCast comes in. GraphCast is, again, I would define it as a domain-specific gossip network, not just for indexers, but for the graph participants in general. So in technical terms, GraphCast is basically a wrapper over Waku. So we're leveraging all of the great features of Waku, and we are sprinkling a lot of domain-specific logic and functionality on top. So we are leveraging everything that Waku provides out of the box, because we definitely didn't want to develop our own gossip network or anything like that. We're also leveraging the amazing Waku network and all of the architecture, and basically it's amazing because we don't have to think about the gossip network side of things. We don't have to think so much about the P2P messaging itself, because all of that is handled by Waku. And what we do is we use Waku's functions within our own functions, and we add on top graph specific logic. For instance, address checking to make sure that a message sender is actually a participant in the network, that they're actually an indexer. And of course, within our messages, our message content is relevant to the graph. Now, in terms of projects that use GraphCast, the biggest one is SubGraph Radio. SubGraph Radio is an app. I mean, it's basically a REST app that comes in all sorts of flavors. People can run it as a Docker container. They can run it within their Kubernetes setup, hopefully by using Launchpad. But even if they're not using Launchpad, we provide a Helm chart for SubGraph Radio. So SubGraph Radio is a REST application that can be ran in a variety of ways. It's pretty lightweight. It's pretty efficient. And what it does is it gossips. So for instance, if I am an indexer, and we at GraphOps, we are an indexer also, and we are using SubGraph Radio. So SubGraph Radio computes, I mean, it doesn't compute because it's already computed, but it takes the proof of indexing hash, which is a hash that's basically calculated from the GraphNode database. So like, let me just take a step back. When an indexer syncs subgraphs, they compute a proof of indexing hash, which is just, a simple string hash. And there is a proof of indexing hash for each subgraph on each block. So the reason the proof of indexing hashes exist is because obviously this is a decentralized network of indexers. So you want to make sure that all of the indexers have the same data, because you don't necessarily, like as a user, you don't necessarily care which indexer specifically you're getting your data from. Sorry, there seems to be sound outside. I hope the team can get this.
Oh, that should be fine, I think.
Okay, let me continue. So as a user, you don't necessarily care which indexer you're getting your data from. You just care that your data is valid, your data is fresh, your data is verified, and all of that. So you would not get your data from a specific indexer. You would get your data by querying the graph network as a whole. That's why it's essential for all of the indexers to have the same data in their databases. So proof of indexing hashes basically help with that. Now, How does subgraph radio help with that? Subgraph radio lets indexers in an automated fashion. So they just run the radio, and it, at a given interval, it sends off the proof of indexing hash for a given subgraph in a given block out to the GraphCast network. And other indexers who are also running subgraph radio, they receive proof of indexing hashes. I'm just going to call them POIs for short. So they receive POIs from other indexers, and they compare it, like, not manually. All of this is automated by the radio, but the radio receives POIs from other indexers, and it compares it to the local POI that the indexer has computed, and checks if they're the same. Essentially, what the radio does is pretty simple, but it helps with network consistency of data a lot, because if it sees that the POIs are the same, then everything's fine. If they're different, though, and if the user has set up Slack notifications or Discord notifications or whatever, we support a wide variety of messaging bots. So if it detects a divergence and the user set up notifications, the user will receive a notification. The user can go one step further and tweak the logic to do different things when the radio detects a divergence, but this is what comes out of the box. We also provide a HTTP server with a GraphQL API, so the user can at any point dig deeper into what subgraphs have diverged POIs, what subgraphs are matching. It also has a Grafana dashboard, so all of this is visible in a great UI-friendly way.
Cool. So I know there's a lot of projects in the Web3 space which claim to be decentralized, but they still end up using centralized indexing solutions. I think GraphCast solves this problem in a very novel approach by using Waku for decentralizing your indexes. So can you tell us more about this in a technical perspective?
Oh, a lot of projects really claim to, like, as you said, that they claim to be decentralized, but there's this saying that a system is only as strong as its weakest link, right? And that kind of means that your system is only as decentralized as your most centralized component. So if your indexing is centralized, you're not really decentralized. I would even go one step further. I would say if your messaging and signaling layer is not decentralized, you're also not decentralized. So now for the specific question of how we use Waku, so we separate GraphCast between the GraphCast SDK and downstream radios. So subgraph radio is a REST app that uses the GraphCast SDK. GraphCast SDK is also built with Rust, and huge props to the Waku team for providing Rust bindings, because that's what we use. We use the Waku Rust bindings in order to facilitate everything that we do in the SDK. Now, how we're using Waku, basically, currently, the SDK is set up in a way that, by default, all of the downstream radios are acting as Waku relay nodes. The reason for that is because the nature of our app is such that we want to make sure that all of the participants receive the POI messages in time. So we want to make sure that they receive them for sure, and they receive them fast. So that's why all of the subgraph radio instances are effectively Waku relay nodes. Now, we do use our own pub subtopic, so we don't use the default Waku pub subtopic, but that's mainly to not spam the wider Waku network, because we do have a lot of messages that are very domain specific. We do have a few boot node fleets. We have one boot node fleet with a few nodes. Those nodes are using NWaku, which has been performing really well. We previously used GoWaku, but now we use NWaku for those. But really, the thing that helps us the most is that a few nodes in the main Waku network support our pub subtopic, which is great for our message propagation. Aside from using the Waku REST bindings, we also have plans of using JS Waku for a few web-based apps. For instance, we really want to allow other network participants, such as subgraph developers, to participate in the GraphCast network. And one interesting use case for that is, currently within the network, we have this problem, which I'm going to try to explain briefly. And I think Waku and GraphCast can actually solve that problem. So right now, when a subgraph developer publishes their subgraph in the Graph network, they rely that indexers will manually start syncing the new version of the subgraph, because the indexers are syncing and serving data for the old version of the subgraph. And that's not very seamless, because the indexer has to either go and check if there are new versions, or they have to rely that the developers will send messages in shared channels, which, as we all know, is definitely not effective. So what we really, and this functionality is supported on subgraph radio side, but we still haven't created a easy way for subgraph developers, which are not necessarily very technical, or we have a lot of situations where there's a team that they have one subgraph developer in the team, but then they have another person which might not be technical at all, but they handle the manual side of things, like publishing a new version of a subgraph, because that can be done with no development effort at all. So we really want to bridge the gap between subgraph developers and just in general users of the graph that rely on the decentralized indexing network and indexers. So the way we will do that is by using JS Waku to have a web interface integrated both in GraphSphere and hopefully in the Graph Studio website itself, that allows people to send messages onto the GraphCast network, specifying the new hash of the new version of the subgraph, and specifying that they will release a new version, and that they can even specify when they will release it. So this is amazing, because this will enable indexers to not think about this at all. Like, they will automatically, when they receive and validate this message, they can start syncing the subgraph, so that when the subgraph developer publishes it, the data is already in the indexer. Because this is another problem. Even if the indexer knows that a subgraph developer has published a new version, they currently, most of the time, they start syncing it at that time when it's published. But if the subgraph is huge, it can take up to a day or two to sync all of the data. So you have this time where the indexer is serving old data. And, in some cases, that data can have issues. That data can not be valid. So we really believe that using Waku, we can solve this subgraph versioning issue that we currently experience.
That's amazing. So I always love asking this question to our ecosystem partners, but what made GraphOps pick Waku over the other communication alternatives in the space? So you had a choice to use libp2p directly rather than using Waku, but what made you pick Waku over the other approaches?
That's another great question. I mean, really, we spent some time researching alternatives, but at the end of that research, there was no question about it. Like, Waku is very, very battle tested. So we know that what you guys claim to do, we know that you actually deliver it. Like, we know that you bring all of these guarantees on top of libp2p functionality, and really, like, it would have been a huge, I think it would have been a big waste of time if we were to implement a lot of these things on our own. And you guys have specialized in Web3 messaging for a long time. So really, it wasn't a big question. Like, Waku, to be honest, was a clear winner in that competition for our use case. We also really wanted to work alongside you guys because, again, like, we really respect what you're bringing into the Web3 space in general. And I think this cross-team collaboration between Waku and GraphOps and TheGraph can really bring wider benefits to the whole Web3 ecosystem. So really, I don't have much to say here because Waku was a clear winner. We did have a blog post on the Graph's forum, specifically highlighting why we will go ahead with Waku for GraphCast. So we can link that, I think, in the notes if people want to check it out.
That's cool. So how was your overall building experience with Waku? Did you find the Waku co-contributors supportive, and how were the protocols and SDKs for you?
I think all of our communication with Waku has been more than seamless. The support on Discord is very fast. I'm really impressed. Like, there's been a few times where I've opened, or someone else in our team has opened PRs to the Waku risk findings repo, and we immediately get feedback. We immediately get advice and help from the Waku team, and we get our PRs merged. Even in some occasions, Waku devs have checked our repositories. So again, like, the whole of GraphOps is really thankful to Waku for all the support. We found that both the TypeScript implementation that we started with and the Rust implementation that we went ahead and released with, both of them are great. I'm really excited. I'm hearing that there's plans to invest more into the bindings and to maybe use NWaku instead of GoWaku as a base for the bindings. So there's a lot of things that I'm excited about on the Waku side for the future. But so far, our experience has been, pretty seamless.
Perfect. So I'm really excited to know what are the next exciting things for you on your roadmap for the next couple of quarters at least. Like, do you have anything that you want to highlight to the community on what you're working on right now?
So I think I probably the team will agree, but for me, there's a few very exciting things that will make our work streams converge and fit together. So I mentioned that we are really working hard on improving GraphSphere, which is our Graph Explorer type website, but it's going to flourish in other Web3 centric features. But I don't want to get too much into it because I don't know how much of that I can share. But GraphSphere will be a huge priority for us, and that links with GraphCast and Subgraph Radio and our collaboration with Waku, because we want to build all of these web native functionalities for GraphCast within GraphSphere. So, for instance, the functionality I mentioned about subgraph versioning, we definitely want to have that built in GraphSphere so that users can use the web interface of our Explorer, send messages onto the GraphCast network, possibly using JS Waku under the hood, in order to notify indexers about new subgraph versions. So, yeah, to me, like, I'm really excited to see that GraphCast, which until now has been mostly focused on indexers and has been mostly used as a CLI application or as a Docker container, I'm really excited to see that moving on to the web. I guess another thing is we are working on aggregating all of the network data from GraphCast. We're working to kind of summarize all of that in a great UI page again on Graphs here, which will be really cool because that will give insights on all of the traffic within GraphCast, but essentially within Waku in our use case as well. So it'll be pretty interesting to see things like total numbers of subgraph radio instances being ran, total number of subgraphs that are supported, but also just network data, which is essentially Waku network data as well, because we want to be able to display things like message sending times or like message throughput of different radios. So yeah, just maybe like to summarize, I'm excited about all of our work streams converging, and a lot of the work that we've done on GraphCast in collaboration with Waku. I'm very excited about that hitting the web. That would be pretty cool.
Cool. That sounds amazing. So it was nice talking with you, Petko. I think we had a great conversation, and I'm sure the audience enjoyed it as well. So finally, on a closing note, for someone who is watching this video, what are the best resources to get started? How can they dig more into the graph and GraphCast? So what are the pointers that you wish to hand out?
For sure. So I think the main place to contact any of us would be the Graphs Discord server. There is a channel specifically for GraphCast, but also all of us at GraphOps have a role that says GraphOps, so you know that if you're not going to be scammed. I would suggest that anyone who wants to learn more about our tech initiatives, definitely visit docs.graphops.xyz. You can also check out our beautiful Graph Explorer that we launched last month. So that would be graphshere.com. So I guess those are the main ones.
Awesome. Thanks for your time again, Petko. And for every one of you out there, make sure to join our Discord community. It's on discord.waku.org. And also make sure to follow us on our Twitter handle. We usually post out our regular team updates over there. So yeah, I'll see you in another video.